Hello everyone. Today we are going to discuss about tips and tricks of mole concept. Before going to exact concept, first we discuss about some important terms related to mole concept. In that first one is atomic mass. Atomic mass is nothing but mass of one atom. And molecular mass is nothing but mass of one molecule. Molecule is a group of atom. Mass of one molecule is called as molecular mass. Then a molar mass. Molar mass is a mass of 1 mole of particles, that is called as molar mass. It is nothing but mass of 6.022 into 10 raised to 23 particles. Okay, mass of this much of particles is known as what? Molar mass. Those particles may be atoms or molecules. In case of atoms, the molar mass is a gram atomic mass. In case of molecules, the molar mass is gram molecular mass. Okay. For the further calculation, we must know about atomic mass of some important elements. Okay. Say for example, atomic mass of hydrogen is 1. Atomic mass of carbon is 12, atomic mass of nitrogen is 14, atomic mass of oxygen is 16, so on. Okay. Next we move towards calculation of molecular mass. Here we write the mass of nitrogen. We already know that mass of nitrogen is 14. 14 U means atomic mass, 14 gram means this is a gram atomic mass. Next we move towards calculation of molecular mass of the given compound or a molecule. Here example number 1 is water. Now we are going to calculate molecular mass of water. Already know that the mass of hydrogen is 1. Here 2 hydrogens are there. Therefore 2 into 1. Plus mass of oxygen is 16, therefore this is 18. So mass of water molecule is 18U. Like that, mass of calcium hydroxide. Mass of calcium is 40 and 2 hydrogens are there, 2 oxygens are there. Therefore we get what? 74U. By simplifying it we get 74U. Next we move towards water molecule. Here the mass of water is 18U or 18 gram. 18U indicates molecular mass and 18 gram indicates gram molecular mass. If we take atom, that is gram atomic mass, here we taken a water molecule, therefore this is gram molecular mass. Okay. These are some basic points regarding to mole. Okay. Next we have to move towards exact concept mole. Okay. 1 mole is nothing but exact concept mole. 1 mole is nothing but 6.022 into 10 raised to 23. Okay. This is also called as what? Avogadro's number. This is Avogadro's number. 1 mole is nothing but 6.022 into 10 raised to 23. As like 1 dozen is nothing but what? 12 units. Like that 1 mole is nothing but 6.022 into 10 raised to 23. In case of atoms, 1 mole equal to 6.022 into 10 raised to 23 atoms. This is also equal to gram atomic mass. In case of molecules, 1 mole is nothing but 6.022 into 10 raised to 23 molecule. This is gram molecular mass. This is a very important point. So 1 mole is a unit which is used to calculate amount of substance. We use a unit that is called as what? 1 mole. 1 mole is nothing but this much of value. Means 1 dozen is nothing but 12 units. Like that 1 mole is nothing but 6.022 into 10 raised to 23 units. In case of atom, this is again equal to atoms. In case of molecules, 1 mole equal to this much of molecules. In case of gases, okay, 1 mole equal to 6.022 into 10 raised to 23 particles means 22.4 liter. This is again equal to molar volume. If they given molar volume, that is again equal to 1 mole. So 1 mole equal to 22.4 liter, or again this is equal to molar volume. Is this clear? So this value is in case of STP. if gases are given at STP, then only we can use this value. Okay, STP means at a standard temperature and pressure. Here pressure is 1 atm and temperature is 273 Kelvin. Okay, next we move towards very important concept of this video. That is some important formulas of the moles concept. Okay, some important formula to calculate moles or mass or gram molecular mass or volume or number of particles or given mass. Okay, is this clear? For that, first formula is to calculate number of moles. N is nothing but water. Number of moles. To calculate number of moles, we may use this formula. Totally four formulas are there to calculate number of moles. In that, this is first one, second one, and third one, and this is fourth one. First, we move towards first formula. First formula is N equal to M divided by gram atomic mass. Here N is a number of moles. Okay, M is a given mass. M is what? This is a given mass divided by gram atomic mass. This is nothing but molar mass. Okay, M divided by M. M divided by M. M means mass given divided by molar mass. Okay, and the second formula is again mass given divided by gram molecular mass. If the molecule is given, then we can take gram molecular mass. If atom is given, we can take atomic mass. This is a difference. Okay, both the formulas are same. Okay, formula is like this: N equal to mass given divided by molecular mass. Or molecular mass means in case of atom this is atomic mass, in case of molecule this is molecular mass. Is this clear? And third formula is N equal to capital N divided by Na. Here Na is Avogadro's number. This capital N is nothing but number of particles. If number of particles are given, we can easily calculate number of moles. So number of moles equal to number of particles divided by Avogadro's number. Is this clear? In case of gaseous substance, the number of moles are calculated by using this formula. Okay, N equal to V divided by 22.4 liter. Is this clear? So first formula is mass given divided by gram atomic mass. Atom is given, we can take atomic mass. If molecule is given, we can take molecular mass. Both the formulas are same. And in third formula, if particles are given, we can calculate number of moles by using this formula. Okay, if gaseous substance is given, we can calculate number of moles by using this formula V divided by 22.4 liter. Means here V is a volume. If volume is given, we can use this formula. Okay, next we move towards example. Okay. Different examples to calculate moles. Okay, first numerical, calculate, wait a second, calculate number of moles in 392 gram of H2SO4. Number of moles in 392 gram of H2SO4 means here mass is given and compound is H2SO4 means this is a molecule. Okay, therefore formula is mass divided by gram molecular mass. Given mass is 392. Okay, molecular mass of H2SO4 is 98. By calculating, we get what? 98, because mass of hydrogen is 2, sulfur is 32, oxygen is 16. 4 oxygens are there, 4 into 16. By simplifying this, we get mass of means molecular mass of H2SO4 is 98. 392 divided by 98, we get this much of mole. Okay, please you calculate this one. Next we move towards second numerical. Calculate number of moles in 44.8 liter of carbon dioxide at STP. Okay, so here at STP gas is given. That given gas is carbon dioxide. Volume is what? 44.8 liter. Directly we can use this formula. Number of moles equal to volume divided by 22.4, because this CO2 is what? Gas. If gas is given and here volume is also given. Therefore we can use this formula. Okay, in previous formula what they given? Mass given. Okay, therefore we calculate molecular mass, finally we get what? Number of moles. Like that, here in this numerical volume is given, therefore we can use this formula, N equal to V divided by 22.4. Therefore V equal to what? 44.8 divided by 22.4. Okay, is this clear? Next concept is again a important concept, how to convert grams into moles or volumes into moles. By using same formula we can calculate grams into moles, or we can convert moles into liters or liters into moles, like this. Okay, for that take a example, very important example. Calculate, the numerical is like this, calculate number of atoms of the constituent element in 53 gram of Na2SO4. Okay, so now in this numerical, mass is given and the compound is Na2CO3. First we can calculate number of moles. By this again we may calculate number of molecules. By this finally we calculate number of atoms. Therefore we calculate number of atoms here. So the procedure is like this. Again mass is given. Mass is what? 53 gram, and gram molecular mass means molecular mass of Na2CO3. Na is 23. Okay, carbon is 12 and oxygen is 16. So by simplifying this we get what? 106. Okay, therefore moles equal to mass given divided by molecular mass. Mass is 53 divided by 106 is what? 0.5 mole. Okay, 1 mole contains 6.022 into 10⁻23 molecules. Therefore 0.5 moles contains 3.011 into 10⁻23, means here 0.5 into that Avogadro's number. Avogadro's number is nothing but this number. Okay, 0.5 into 6.022, we get 3.011 into 10⁻23 molecules. Okay, now we get molecules. By using this molecule, finally we may calculate the atoms for present in this molecule. Okay, 2 sodiums are there, 1 carbon is there, and 3 oxygens are there. Here we get this much of molecules. In that, particularly for sodium, 2 sodiums are there. Therefore 2 into this value we get a number of sodium atoms. Only 1 carbon is there. C into this value we get carbon atoms. Again 3 oxygens are there. 3 into this value we get this much of oxygen atoms. Is this clear to everyone? Okay, listen once again. Here they gave molecule and its mass. Okay, this is given mass and compound is Na2CO3, and they asked to calculate number of atoms. For that, first we calculate number of moles by using this number of molecules after number of atoms. Okay, is this clear? First we have to calculate number of moles. Here number of moles is 0.5. By using this, finally we may calculate number of atoms. Is this clear? Understood? Okay. Next we move towards one more numerical, that is calculate number of moles in 350 cm3 of CO2 at 273 Kelvin and 2 atm pressure. Okay, here they gave the gas, but this is not in liter. This is first point. This is given in cm3 and at 273 Kelvin, but pressure is 2 atm. For standard condition, what is the condition? Here pressure is 1 atm, but here they given it as a 2 atm. First we convert it into standard condition. Therefore, how to convert this? We convert this into standard condition. How to convert this? By using a formula, by using a simple formula, that is P1 V1 divided by T1 equal to P2 V2 divided by T2. This is ideal gas equation. By using this equation, first we have to convert this into standard condition at STP. It is not there in STP. First we convert this gas into STP. Okay. Here P1 V1 T1 as P is a given pressure, that is 2, and V1 is a 350 cm cube and T1 is same 273, T2 is also 273, and here P2 is 1 atm standard and V2 we can calculate. By simplifying this, we get V2 equal to 700 cm cube. This is not in liter, therefore we convert it into liter. 700 divided by 1000 equal to 0.7 liter. Okay. Now finally we get the volume of gas at STP, that is 0.7 liter divided by 22.4. Okay. Why? Because here formula is what? Formula is given volume divided by 22.4 for calculating number of moles. If gas is given, we use this formula. But this gas is not at STP. Therefore, by using ideal gas equation, first we convert it into HTP. We get it as a 0.7 liter. Finally, we calculate moles. Is this clear to everyone? These are some easy or important numericals on the topics of moles concept. Okay. Thank you everyone.